Okay, folks, so welcome back to another session. We're going to go ahead and get it cranked out tonight. We're at Module 5, page 27 in the field safety book. So let me go ahead and go to that book so everyone knows which book we're on. As we've already discussed, we went through the safety orientation book already. Now we're in the field safety book and trying to wrap this one up by either Thursday or by this coming Tuesday. And then we'll be going over to the safety technology book, the third book, okay? I've talked to some of you already. We're actually uploading all of the previous sessions now to YouTube, in addition to all the new sessions that will be on YouTube as well for anybody who wants to proceed forward without having to wait all the way through the next few weeks, okay? So that was the first book, folks. There we go. There's the field safety book, and that's where we're kicking off tonight. We're kicking off on Module 5, Section 3, which is page 27, and we're going to be talking about aerial lifts and qualified operators, okay? So let's go to that page, and as we normally do, we'll go ahead and go through the green section first, the trade terms. And as you see, there's only 3 trade terms in this one. First one being aerial lifts. What are we talking about? It's a mobile work platform, and it's basically designed to transport and to raise personnel, tools, materials, or any other overhead work areas, right? So we can do our work in an elevated state without actually having to be on a scaffold and or a ladder, where it may be more practical to be an aerial lift, or it may be also the only possible way to get up there in some cases, okay, and then second one is interlocking systems. What are we talking about? We're talking about basically control systems, and basically they're set to prevent any type of accidents or any type of incidents, and by keeping one system from overriding the other. So what are we talking about? It could be like a tipping moment switch where it will not allow the lift to go out any further because it may be sensing an imbalance in the piece of equipment. It may also shut us down depending on the hazard associated or electrical arc as well, okay? And then ultimately is proportional controls. What are we talking about? It's basically a control that's going to increase the speed, right, in proportion to the movement of the control. So it's basically going to be like a governor or an idle, and it's going to control our speed in that piece of equipment so that we are less at risk of harming ourselves as well. So if you go to section 3.1.1, aerial lift operator qualifications, and we're looking at page 27. Now, folks, let me tell you what we're going to do. For the next few minutes, we're going to talk over the next 4 pages, which is all aerial lift requirements and qualifications. And then I'm also going to show you some things in the OSHA standard. I think I've shown them to a couple of people before in the safety orientation book. We're also going to go ahead. I'm going to show you a manual for an aerial lift for a JLG and one for a Genie, and I'm going to show you some issues that are in there, okay, so we can talk about them as well. One last thing, folks, I did notice, and I'm realizing that those of you that are on tablets or those of you that are on phones, that you really can't type back because you have to go out of the video. So don't worry about it, okay? If you don't type in, even if I ask a question, just don't worry about it unless you want to. If it's easier just to stay on the screen that you're on, please, by all means, do so, okay? And then any of you, those that are on a computer, if you can chime back in, great. And if not, we'll just keep it moving as well, okay? Okay, so first of all, who can operate and who can be on an aerial lift? Only people that are trained, only employees that are trained, and employees that are authorized, okay? Now, I want to bring something to your attention. And if you recall, when we talked about the 3 different classifications or the 3 different types of scaffolds, aerial lift is one, okay? So remember that a pole scaffold, right, like basically a wood scaffold or a tube and coupler scaffold, something coming from the ground up would be a supported scaffold. And then anything being suspended or being hung from the top down, and particularly things like swing stages, window washing scaffolds, or boatswain chairs, items like that, that are also classified as scaffolds. And then, of course, the third one being aerial lifts. Okay, scissor lifts do not fall into the aerial lift standard. Those will be completely different. They'll fall into more powered industrial trucks. But as far as aerial lifts, they're all actually in the OSHA scaffold standard. Okay, but that being said, I wouldn't treat them any far differently. They're both scissor lifts and aerial lifts, are both obviously, as we all know, are significant risk. So we want to make sure that we operate them safely. And I usually tend to try to stick to the same standards. Okay. All right. So let's go ahead and talk about it. So ultimately, what do we have to do, right, for safe operation? That the operator's got to be able to understand all the hazards, the warnings, the limitations, right? All the procedures and the requirements for maintaining an aerial lift. That's basically the most important part, is that we have to have a qualified operator. Okay. And of course, the piece of equipment, that piece of equipment must be in good safe shape as well. And then in addition to that, we'll have different requirements that are often required for operators to meet. And basically, number one, it's going to be that they're going to have to understand and they're going to have to be familiar with the associated operator's manual. So if they're on a JLG, they need to have access to the operator's manual for that JLG aerial lift. Or if they're on a Genie, they'll have to have the one for the Genie. Okay, they also have to understand the procedures and warnings in the operator's manual and those that are posted all over the aerial lift as well. That's why it's important that we have that manual and all the warning decals and instruction decals and all the instructions for operator use. They must be legible. Also, we have to be familiar with the employer's work rules and any government-related standards like OSHA standards. And then basically, an operator's got to be able to demonstrate their understanding, right? Operate the associated aerial lift during training in the presence of a qualified operator. So we talked a few weeks ago, if you recall, folks, we talked about powered industrial trucks. And we talked about the requirements for a powered industrial truck operator. And let me go to that. I'm going to go to the internet, and then I'm also going to go to one of the sheets that we have as well. And the reason I bring this up is for two reasons. First of all, I want you to remember this, is that the OSHA 1910.178, that's the powered industrial truck standard. An aerial lift is two things, folks. An aerial lift is going to be a scaffold because it falls under the scaffold standard. I'll show you that standard number in just a second. But in addition to being a scaffold, it's also a powered industrial truck because it's motorized and it moves. Okay. So what I'm doing is I'm coming here to the powered industrial truck standard 1910.178, and I know it's section L just because I deal with it on a regular basis. So I'm just kind of fast forwarding down to section L so we can kind of talk about a few things. And we've talked about this in the past when we talked about powered industrial trucks, but I just want to cover it one more time. And basically what I want to talk about is operator training. And here's your standard right here for operator training. Okay, training, what does it have to consist of? Excuse me one second, I'm trying to enlarge it a little bit for us, folks. Okay, so what does operator training have to consist of? It's going to be right here. Training has to consist of a combination of formal instruction. It could be lecture, discussion, interactive computer, LMS, basically. It can be a videotape or any type of written material. Second of all, it's going to have to also have practical training. Basically, it's hands-on by the trainer with practical exercises for the trainee. So we're basically showing the trainee, if we're the trainer on record, we're actually showing the employee how to use the piece of equipment or the machine, what the hazards are associated, and then we'll let them practice on it. Okay. And then and it's going to be in an area where an employee is not going to be at risk to themselves or to other employees. And then ultimately, we must evaluate that operator's performance in the workplace. Okay, so we can't send them out to a third party and have them evaluated off-site. They're going to have to be evaluated in a particular workplace where they will be working. Okay, so those are the three requirements. After that, the employer is going to have to certify. Now I'm going to kind of fast forward through with the Control F again or the Command F again. Okay, and I just want to show you. Here you go, right here. Employer, right here's where it says the employer has to certify that each operator has been trained and evaluated, okay, as required in section L, which is paragraph L, which is what we just saw. And what the certification is going to have to include is that at a minimum, the name of the operator, the date of the training, and the date of the evaluation, okay, and the identity of the person performing the training or evaluation. So let me show you the form that we have, and I'm glad to send it to you all, folks, also. Okay, let me go ahead and open up this form for us right here. And give me 1 second. Let me convert this over really quickly It's going to make life easier for us. Okay, so remember, treat it just like a forklift, okay? So here you go, folks. Here's an example. I know the print's not really big, but it's the easiest way to show it to you. Basically, and this is how we do our evaluation form. I'm happy to send it. Let me know. Send me an email if you need it, okay? And if you notice on here, what we did is these are the 25 items that are either recommended or required by OSHA. If it's non-applicable, we'll just put non-applicable. Often we have, if it's not elevated platforms where there's a loading dock, we often don't have bridge plates. So bridge plates will often right here, ramps or bridge plates will often be checked NA. Everything else, or just about everything else, we have to wind up checking yes. Okay, and this is a form that we built. If we have any no's at all that we check during the operator qualifications, right here, you'll notice it says that the trainee is going to have to be retrained and reevaluated. Okay, information that OSHA wants, they want the name of the operator, they want the type and class of vehicle. Right there, we'll just put a JLG scissor lift or aerial lift, whatever the case is. The knowledge or formal based training, the practical training, and then the evaluation, the 3 items that they ask for. And then ultimately down here is just an employer certification that we drafted. So whoever's reviewing this file for the employer, let's say for some reason our company went in or you brought in a third party, or you had different people. You may have one person knowledge training them, second person practically training them and or evaluating them, or maybe even a third person. And then whoever's responsible for verifying and certifying that that employee has been adequately trained, knowledge-based and practically trained, and then verifying that that employee has been evaluated would then print, sign, and date. And they are representative of the employer certifying that the employee has been adequately trained, okay, and evaluated. So that's basically the form that we use there, folks, okay? And then in addition to being a powered industrial truck trained, let me bring you over to the OSHA standard now for aerial lifts. For aerial lifts and scaffolds. So this, like I said, was 1910-178. That's for the mechanized portion of that aerial lift, okay, or scissor lift. Now I'm going to 1926. Now I'm in construction. General industry standard for powered industrial trucks applies to construction as well. That's why I was in 1910. And now I'm going to 453, which I'm going to show you folks is aerial lifts. And I just work a lot with this standard, so that's why I kind of know where it is. And here you go, folks. Here is the requirements for aerial lifts. That's 1926 453 if you need to get to it. And then all the training is going to be in 1926 454. That's for all types of scaffolds, including aerial lifts. Okay, so now I'm going to come here to 454. And now these are the training requirements for all types of scaffolds, including pole scaffolds, suspended scaffolds, and aerial lifts. Okay, folks? So there's the standards that you would follow. And then we're going to go ahead and move on, okay? So let's talk about a few things, folks. I'm going back to page 27 now at the bottom right. And the following list of requirements, right, that we talked about: understanding the associated hazards in the manual, understanding all the procedures and warnings, being familiar with the OSHA's work rules and OSHA's requirements, and then demonstrating that they understand how to operate the associated personnel lift or aerial lift, which is exactly what we were just talking about, okay? And that covers what we just talked about on page 27. And now I'm moving over to page 28. And there you'll see the illustrations of a few different ones. For anyone who's not familiar, an aerial lift is the boom supported work platform that you see it on your left-hand side. There's an example of an aerial lift or a boom lift, whichever one you want to call it. To the right, you'll see your scissor lift. Scissor lift will only go straight up and down. It will not articulate out. And then there's a better example of your scissor lift down at the bottom. And it shows the 3 main components, which is being the base or the motorized base, the lifting mechanism, and then the platform. Okay, so there's your 3 major components of an aerial lift. So what are we talking about now when we're talking about aerial lift safety precautions, right? And like I said, this book, it's showing both scissor lifts and aerial lifts, but like I said, the OSHA standard does not calculate a scissor lift as an aerial lift or as a scaffold, but I treat it as such. Okay, as a best practice, I like to treat it as such. So what are we talking about? We're talking about aerial lifts that safety precautions that are unique to aerial lifts, right? And we have to go ahead and discuss them and cover them with employees. Each manufacturer is going to have certain specific precautions, and I'll show you a couple examples of those. And then, of course, that's where you see where OSHA 1926 453, which is what we just talked about, goes ahead and points out all the requirements of an aerial lift. Okay, so what do we have to do? Avoid using the lift outdoors in stormy weather or in strong winds. Why? We want to be cautious of hazards of lightning that are related to lightning, and then also wind, right? Possible tipping or maybe pushing us into energized components or whatever the case may be, or other hazards. Also preventing people from walking beneath the work area of the platform. No one should be underneath that platform, and for any reason, if anybody is required to go under it, my recommendation is always to be brief and to use a spotter. Okay, and of course our PPE. Uh, Third bullet point there is use of personal fall arrest equipment, a body harness, lanyards, as required for that type of lift being used. Okay, and we have to have approved anchor points, and I'm going to show you some examples of those. Of the body harness and or lanyard and or body belt in just a moment. Okay. Also, do not use an aerial lift on uneven ground. Lower the lift and lock it into place before moving the equipment. Also, lower the lift, shut off the engine, and then set the parking brake right and remove the key before leaving it unattended. And then ultimately, standing firmly on the floor of the basket or the platform. We don't lean over the guardrails, okay, and we never stand on the guardrails either. And then in addition to that, we don't sit or climb on the edge of the basket or use planks or ladders or any other devices to gain additional height either. If we don't have enough height, it probably means we don't have the correct aerial lift. Okay, so let me show you something, folks. So you see a regular aerial lift there, and then let me see if I can pull up the knuckle boom for you really quickly. For anyone who's not familiar, this is what I'm talking about when I talk about a knuckle boom or a lift. I'm talking about one of these right here, where you see this additional, part right here. And what it does is it'll allow an employee to bend up or down, articulate left and right often. Okay, so it's called the knuckle boom. Some of them have it, some of them don't. Regular would just be called. I usually just call them a regular lift, and then I'll call our aerial lift, and then I'll call it a knuckle boom lift or a knuckle boom aerial lift. Okay, a boom lift and then a knuckle boom lift. So just so you know the difference for anybody who's not familiar with it. Okay, so there you go. They even come in toys. Okay. All right. In addition to that, let's see what else. Right, aerial lift operating procedures. The following procedures for scissor lift types or self-propelled aerial lifts. Right, we have to remember that the operating procedures, they're going to vary from model to model. Also, the operator has to become familiar with all the operating procedures, controls, safety features, and then any associated safety precautions. Right before they try to operate that type of lift, particularly. And then a typical proportional control procedure, which it can involve, right? Operation of the levers, hand levers, foot pedals or foot levers also. And then also the farther control is moved, the more power is applied, right, to the motor as well. And then the faster the aerial lift is going to move as well. So basically the controls, they go by pressure. So the more pressure we put, the faster and further out it's going to move, okay? Also, the following tasks have to be performed before operating that lift. What are we going to do? We got to carefully read and fully understand the operating procedures of the operator's manual, and then any warnings and instruction or decals. In addition to that, we have to check for obstacles around the work platform, right? Anything that's going to be in that path of travel, anything like holes, it could be drop-offs, debris, ditches, it could be soft fill. We're looking for anything that may be affected where the weight of that vehicle and while we're operating it may be affected by substandard ground conditions, okay? We also have to check for overhead clearances. We have to make sure that we stay at least 10 feet away from power lines if they're under 50,000 volts. If they're over 50,000 volts, we're going to have to be staying at least 20 feet away, if not more. And then we really need to check with the utility companies. If you don't know what type of power is coming through a utility line, we need to call 811. Need to call the power company and get that information from them. Okay. Also, we have to make sure that all guardrails are in place and that they're locked into position. We have to perform the operator's checklist, the checklist that basically comes with the manual, and we have to check for all the components for fluid levels, right, including fuel, oil, hydraulic fluid, coolant levels, all of the liquids and fuels that we need to check on that vehicle to make sure that it's performing safely and optimally as well. And then we never make unauthorized modifications to that aerial lift. Okay. So those are all requirements that we have. And then if we're talking about safe operation of a scissor lift, what are we talking about, right? We're talking about same power lift. Now it's a scissor lift, and we know that they use hydraulic rams, right? They lower and raise the platform. It's going to be one solid or one smooth. It should be one smooth elevation up, one smooth elevation down. It depends. It may be propane operated. They may be gasoline or fuel or diesel operated. They may be battery operated as well. So they all come in different sources of energy. And so we also need to be aware of the types of hazards associated with the form of energy that we're using or fuel that we're using in order to power that device, okay, or that piece of equipment. Also, some models include an operator station at the ground. They also call it the dead man controls in our industry. And what's it mean? It means that they're supposed to be able to be controlled from the bottom as well, just in case an employee loses consciousness, is incapacitated, or dies up there. Look on page 28, folks, and you'll see the controls there. If you look on the JLG on the boom lift, right above the rear right tire that you're looking at, right on the left-hand side of where it says JLG, those are actually the controls. It's just a little hard to see, but those are actually the controls. Okay, so let me do this. Let's do dead man controls. And that's what I'm talking about is as lower. Let's see. Let me try lower controls maybe. Might not be a good thing to call them dead man controls. So just depending on the piece of equipment, okay, they're going to have controls up top, and then let's see. Here's an example of one right here, folks. That's what I'm talking about right there. Those are the power controls or the dead man controls. Okay, so you'll find them on scissor lifts, you'll find them on aerial lifts, you'll find them on all types of different types of equipment. Okay, folks, here you go. Here's maybe a little bit better shot of it right here, right there. Okay. Okay. So let's go ahead and move on. In addition to that, what are we also talking about, right? Lifting heights and capacities that they're going to vary by model. So things that we have to look at is lift heights, right? They might be as high as 41 feet in a scissor lift, okay, and the capacities could reach up to 2,000 pounds that they could hold. One thing good is that, and a lot of people don't realize this, is that aerial lifts, scaffolds, ladders, as we often talked about ladders and scaffolds, same thing with aerial lifts, they have to hold 4 times their intended weight. So if it's holding 2,000 pounds, most likely it's going to have to hold at least 8,000 pounds, but it doesn't mean we can overload it. Okay. If the limitation on that lift is 2,000 pounds, we have to respect that limitation. Okay. Um, in addition to that, no one's permitted to operate a scissor lift, right, without training or proper operating procedures. So that goes for any type of lift, a scissor lift, aerial lift, or whatever the case may be. And then I'm now moved on to page 30. Also, employees have to read, observe the warnings and cautions, right, that are placed on a unit, right? All the decals that come from the manufacturer or from the employer or the employer's rep. Also, keep the vehicle in a working platform at least 10 feet away from electrical power lines, same as an aerial lift. Is, like I said, if that's under 50,000 volts. If it's above 50,000 volts, and then we're going to have to go ahead and stay at least 20 feet away, and then also determine what the safe distance is, okay? Also, we have to check for loose or missing parts before we operate any lift. Okay, anything that's not working, we have to correct it or we have to take it out of service. If it's any safety device, if it's any safety guard, we have to make sure that they're in place. Okay. And then in addition to that, we also have to not remove any parts or any safety devices like we were just talking about. Make certain that the immediate area is clear of all personnel, okay, and that all obstructions have been removed before, or that we've made considerations before we actually raise or lower the lift, okay. In addition to that, we have to keep the guardrails and chains in place when we're operating a lift. We don't bridge between two scissor lifts or between two aerial lifts, okay, and a building. So basically, you either work off of one. What that means is you either work off of one surface or you work off the other. We either work on one lift or the other lift, or we either work on a structure or we work off the lift. We never work off of two surfaces at the same time because one may fail and an employee may be now either being pulled apart or may fall down, okay, may fall to a lower surface. Also, never crawl into the scissors of at any point of that lift, whether it's energized or de-energized. Never get between those scissors, okay, on that lift. Also, leave any repairs to any qualified repair personnel. If you're not qualified to repair it, which most of us are not, do not mess with it, okay? Also, operate the vehicle on firm, solid ground. Don't operate the vehicle near the drop-off. Don't impose side loads on the work platform. What's that mean? Let's not be pulling on it or tugging on it, okay? Let's not be using it to tow or pull anything off of anywhere. Also, never exceed the rated capacity of the lift, which you talked about, which can be up to that 2,000 pounds. It could be lower. Not operating the vehicle with any explosive atmosphere, LEL atmosphere, right? Making sure that we're underneath that 10% LEL. Never climbing on the railings is another one. And then only operating per manufacturer's instructions. So let me ask you, folks, how many times have you seen employees standing on rails, whether they are working, regardless of whether they're tied off or not? How many times have you seen employees standing on the rails or on the guardrail or the top rail? Okay. Yeah, exactly. Yep. Yeah, we see it quite often. You're absolutely right about that. So let me show you a couple of things, folks. Okay, I've got a couple of aerial lift manuals here, and I'd like to show them to you really quickly. Okay. So let's start with this. Let's start with the aerial lift for a JLG. Let me ask you, folks, who's aware? Let's start with the OSHA standard. Let me back up one step, okay? Let me ask you, folks, who is aware, and I'm going to go back to 1910-453. Who's aware that the OSHA standard actually allows an employee to wear a body belt in an aerial lift? Yep, let me show you. So let me show you, folks, okay? Okay. So this is what the OSHA standard says, right? Doesn't mean what your corporate standard would say. Look what the OSHA standard says. It says a body belt shall be worn with a lanyard attached to the boom or basket when working from an aerial lift. Okay, it doesn't say a body harness. It says a body belt. Okay, now look what it goes on to say here. It says note to that paragraph, right, that as of January 1st, 1998, okay, that part provides that body belts are not acceptable as a form of personal fall arrest. Okay, to use the body belt, it's got to be used in a tethering system or a restraint system, but it cannot be used in fall arrest. So what does that mean? That means that you cannot use it with a yo-yo and you cannot use it with a 6-foot lanyard. What it basically means is that the employee is going to have to be tethered in. So let me show you an example of this. A lot of times you'll see it in a bucket truck. Okay, so let's see. Let's do this. Let me see if I can find this for you really quickly. If not, I may have to find it on the break for you. But basically, a lot of these trucks like this, what they would do in the past is they would actually just have a belt that would be attached to the bucket, where the employee it would not allow them to actually fall out of the bucket. Okay, it was used as a tether or restraint system. So let's do this. Let's see, bucket truck body belt. Let's get rid of Alltech. Okay, so some of these, basically what happened is that they'd have a not as long like this, not a lanyard like this employee has. It would actually just be a tie off and a body belt, and it would be made to keep the employee in a bucket. So there's an example of the belt right there. Okay. And the reason it can be used is because it's not, like I said, it's not being used for fall arrest. It's actually being used for fall positioning. Okay. So it depends on the manufacturer. So I'm about to show you on the JLG. Has anybody ever seen that, folks? Anybody that's out there tonight? So let me show you. Let me show you an example. Let's go to the manual. Okay. The manual I'm in right now, folks, and this one's for a JLG. So let's see what this one says, right? So I'm going with the word body, and let's see what it says. Okay, so first of all, keeping your body parts right inside the platform of the railing that we're aware of. Let's see. Right here, also minimum equipment required, right? Hand, arm, and body protection. And I'm just word searching it. Okay, so now this JLG, if you see here, you'll see that it says during operation, occupants in the platform must wear a body harness, right, with a lanyard attached. So this JLG basically is saying, no, you have to wear a body harness. Okay, so they've delineated now, and they've actually coded up and said that no, we're going to be using a harness in it. So I want to show you a couple things while we're in it. Let's see. I'm looking for one more thing for you also, folks. Okay, so now let me go to that JLG now. I'm sorry, to the Genie. Here's the Genie manual now, right? And let's say we're going to go with the same thing. We're going to search for body. Okay, so we're going to search for belt. And now if you notice, look what they say here now. Now they say that occupants must wear a safety belt, okay, or harness in accordance with the government regulations. So basically what this Genie is saying is that you can use a tether line, right? You see how much shorter that line is? It's only like a 2 or 3 foot line, and they're anchored into the anchor point, and that's not allowing the employee. That's not going to allow the employee to basically fall from the bucket, okay, or from the work platform, and that's why a body belt is acceptable by OSHA, and it's the determination at that point of the manufacturer. Okay, is that understandable? So a body harness with fall arrest, right? Basically being a 6 foot lanyard with a shock absorber or a yo-yo, or a body belt with a tether system or a restraint line only, not allowing you to fall out of the bucket or the work platform unless the manufacturer prohibits it. So examples again, here's your JLG X550A. Like we said, right here, they're requiring a body belt. They're requiring a body harness. Okay, right there, right? They're requiring a body harness. And then, like we said right here, a Genie man lift, personnel lift here. And now they're only requiring a body belt or a harness. Either one is acceptable. Okay. So that's one, folks. Another one I want to tell you, another one that's really like that as well is be cautious of operators exit or employees exiting the vehicle or exiting the piece of equipment, because what happens is if they can't climb on the rails, how can they get out? Okay, so one thing I want you to keep in mind is this: do not sit, stand, or climb right on the platform guard or rails. So if they can't climb on the rails, how is it that they're using it to exit to another work surface? So keep that in mind, because what happens is, do me a favor, folks, chime in the ones that can, and let me know if you've seen a platform or an aerial lift with a gate now, with a swing gate. And I'm going to it to see if I can find one for anybody who's not familiar with it. You're starting to see more something like this, aerial lifts now that have more of a gate on them now. Okay, so one thing you definitely want to make sure is that when equipment is being rented or before the bidding process, is to assure that any aerial lift that you're going to have is going to have a gate if you're going to be allowing those employees to exit the vehicle in order, or that piece of equipment, in order to gain access, like to a roof or something like that. So here's a perfect example right here, folks. You see it right there? That serves as a swing gate. You see it? This gate will open, and the employees can exit from the front of this and exit out of the vehicle onto an elevated work surface. Okay, so definitely make sure, because not all aerial lifts have swing gates, and not all scissor lifts. Well, all scissor lifts will, because they'll be able to ungate or unchain from the backside. And I'll tell you, folks, from having a lot of experience of being in the scissor lifts, it's not the same to be in a scissor lift with chains on the back as it is a swing gate. Okay. Anybody else out there have any experience with scissor lifts with gates or chains? And this is what I'm talking about. I'm about to show you, folks. I'm just going to show you a quick picture. Here you go. Here's a scissor lift, and there's a gate. And instead of a gate, some of them only have two chains going along the backside. Okay, so be very cautious of it. Okay, even though an employee has personal fall arrest on, you definitely want to be cautious of those ones with chains on them. Okay, and obviously always exercising caution. So there you go, folks. There's we read all of the material for when it comes to aerial lifts with NCCER, and then I showed you those differences online. Let me show you one more example also. Anybody who wants me to send you these lift manuals, feel free to, and I'll be happy to send them to you. Okay, and then also what I have here is the look at this from Genie, to whom it may concern. Okay, and this is for their boom lift. Look what the first thing they say here. Okay, that it's prohibited for users to exit that vehicle, okay, without prior approval from Genie. When are they going to give us prior approval? When we have a swing gate, basically, okay, because it's designed for us to go ahead and exit the vehicle. Folks, let me suggest something to you here, right? We're constantly looking for material to train employees on powered industrial trucks, forklifts, aerial lifts, scissor lifts, okay, dozers, street graders, street rollers. I'll tell you this, folks, the best material you can use a hazard awareness video, that's great, okay? Use a PowerPoint, that's great. But the best thing that you can use is the manual for the piece of equipment that you're going to train that employee on, okay, or that they're going to be operating. If it's a tool, the same thing, a manual for the tool that they're using, okay, or if it's a chemical, the SDS that they're using, that they're going to be working with. Regardless of what it is, the best resource that we have is if we know what brand of anything, PPE, material, chemical, okay, heavy industrial equipment, whatever it is, let's use what's relative in the workplace. Okay, so if you can use it, please, by all means, use it. Okay, folks, so we're going to go ahead and keep moving, okay? I'm going to go ahead and I'll get us a break in about the next 20, 25 minutes. I'll get us a break. I want to see if maybe I can push us through one more section and see where we can go, okay? Steel erection, it's not a very long standard, so, excuse me, it's not a very long section, and it also includes a little bit of cranes. So I'm also going to be sending you, I think last week I sent you one video on rigging already. I'm going to send you a second video on rigging tonight or tomorrow for you to watch. I know I kind of loaded up some videos last week. I apologize about that, but I thought they were all really good, relative, and I didn't want some of you to be bored over the weekend, right? So, okay, so let's go ahead and talk about steel erection for a moment, folks. Different hazards, right, that we may encounter. I mean, first of all, let's talk about the trade terms again. And what are we looking at? We're looking at three main trade terms. The first one being a total amount of weight, capacity, right? The total weight of being able to be lifted. Okay, it includes personnel, tools, materials, or equipment. Same thing like a personnel lift. So we're looking at capacity. What are we talking about capacity? It depends. We could be talking about the capacity of a crane. We could be talking about the capacity of an aerial lift if it's being used in conjunction with steel erection. And we can also be talking about the capacity of any type of slings, whether they are synthetic or whether they're wire rope or chain. Okay. In addition to that, connectors, right? What are we talking about? An employee, right, who's working with hoisting equipment, okay, is placed in a connecting structure, members or components. So basically, we're looking at connectors. It may be a person, or it may be the connector, the piece of hooks, shackles, chains, or whatever the case is. And that's normally what they're talking about here. And then last of all, we're looking at controlled deck zone. And what are we talking about? We're talking about an area where there's going to be certain work, right? There's going to be initial installations. There's going to be a placement of metal decking where there are going to be a lot of leading edges where employees may lead to a fall because we're putting decking on, so there's going to constantly be open edges. And then also, where it may take place without the use of guardrail systems. It's not going to be practical to put guardrail systems. So we're going to either have to have personal fall arrest, some type of fall restraint system, or some type of safety net in place. Those are going to be the three ways that we can protect an employee with an open edge. Okay, it's going to be personal fall arrest. So they're going to be in a harness, right? ABC and maybe D's of fall protection. So what am I talking about? Anchor points, right? Body harnesses, connectors, and then possibly decelerators in place too, like a shock absorber. So again, ABCDs, anchor points, body harness, connectors, and then decelerators. All right. So what are we looking at? 1.1.0. We're looking at a wide range of conditions, right? That can fall under the classifications of a job site hazard. Okay, so we're going to talk about a few hazards. Poor housekeeping, of course, could cause slip, trips, and fall hazards. Could cause fire hazards. Could hide sharp edges. Could hide biological hazards, wildlife, plant life. Also, defective or unsafe tools or equipment, equipment that we haven't pulled out of service. It could also be improper ventilation or lack of ventilation, inadequate lifting, could have high noise, could have unsafe storage of flammable liquids or flammable fluids, also slippery floors, poorly constructed and rigged scaffolding as well, and then also improperly stacked construction materials, and then unmarked low ceilings. And of course, power lines, right, and unsafe ground conditions or soft ground conditions. So so the hazards go on and on. Also, as trainees, right, what do we have to do? Well, it's important that we have hazard awareness of safety, right? We also have to understand the hazards that exist, the reasons why the safety rules are in place. We also have to practice following the safety rules, right, until they become a way for us to perform our activity. The safety rules, folks, like I tell people, it should be part of our process, okay? And if you read a process where, in production, we do it all the time, right? Production, construction, and operations, employees receive work instructions on how to do a process, and by doing that process is what will hopefully help keep employees safer. Okay, and safety, folks, is just part of that process. Safety is its own process, and it's also part of the construction operation and manufacturing process. Okay, and construction process. Okay, so of course we have to follow a partial list of hazards, right, that might be encountered in the work site as well. First and foremost, we may be exposed to falling from heights. If we're building, if we're erecting steel, obviously the majority of employees are going to be working at heights. Also, being caught between a stationary object and two moving objects, or it could be being caught between like a railway car. Okay, when the car's unloaded, it could be being caught between two moving objects. It doesn't have to just be one stationary and one moving. Also, being struck by falling materials from above, tools, equipment, right? Swinging hooks, chains, cables. They could be swinging, or they could also pop and fail. In addition to that, it could be hearing damage, right, from continuous noise exposure, or burns and eye damage from welding, cutting, or chipping. Okay, so flash burn, basically, right? Also, sprains and strains from improper lifting or from carrying objects improperly, methods that are improper or maybe excessive weight. Electrical shock from poorly grounded and defective tools and equipment, especially if we're doing some type of arc welding, electrical welding. Injuries due to defective tools or equipment again, and then injuries due to improper tools or equipment or the way that we're using them, right? It could be either a faulty tool, it could be a damaged tool, it could even be improper tool selection. Okay, the biggest thing is we want to stay focused on the job. If we're tired, if we're distracted, we want to immediately stop doing our work in order to help prevent any injuries or fatalities. Also, just remember that just a small lapse in judgment, right, or small lapse in attention could cause a serious injury or accident or fatality. Also, same guidelines should be served, right, when approaching coworkers. It may not only be us doing a job, but it may be a coworker doing a job, and we want to observe the same safety practices. So if we see somebody doing hot work and they're in equipment, if we're going to be within their vicinity, we probably need to be in the same PPE. Okay. Also, we want to wait until they finish their job because we don't want to startle them and cause an issue or hazard that way. Also, the proper use of fall protection, right? The equipment, it's going to help prevent most of the fatalities and injuries. What's the number one leading cause of fatalities in the workplace, in the construction workplace? Well, of course, it's going to be falls, right? Because it goes back to your focus four. It goes back to falls. It goes back to struck bys, caught bys, and then electrical hazards as well. Okay. So, obviously all hazards that we've been speaking about over the past hour. Okay. In addition to that, also we want to make sure that the most common circumstances, like we said, right, falling from a roof or falling from a leading edge. I'm moving on, folks. I'm on module 6, page 2 now. Okay, ladders, scaffold hazards. So we want to be cautious of those as well. They could cause significant fall hazards, and then also we want to make sure that we're working on stable work surfaces. Okay, some risk can be avoided, right, by tying off ladders or properly installing fall protection systems. So, although tying a ladder is not required by the OSHA standard, but tying an unstable ladder is. Okay, so if we're at risk of that ladder losing leverage or possibly sliding on us, yes, we want to make sure that we tie it off. Okay. And then in addition to that, also, we want to make sure that in case of material or equipment collapse, right, we go ahead and we avoid any hazards from any employees being underneath the boom or being underneath the lift. When the worker has to be in a risky position, what do we have to do? We have to have constant vigilance, right? Maybe have a spotter. That's always a good idea. Also, when pieces are being moved of any machine that might escape our control, right, we have to be cautious as well, constantly alert. Biggest thing is we need to make sure that we are securing any loads that we have there to being moved. Okay. The same rules apply for all forms of threats, right? It could be keeping a watch in all directions, especially overhead, right, when we're working around cranes. It could be if a machine is nearby operating, we want to make sure that we're not going to become a hazard to the machine and we won't harm that machine where the machine may harm us in turn. We want to be cautious of any type of equipment that's in kinetic state, right? Basically, it's in movement, like a spinning wheel, right, or some type of drum that might catch the sleeve of the pants of an employee. So we really should not be going over energized equipment, especially something that's in motion. But we know that it's not always possible not to, so we need to definitely operate with as much vigilance as possible and make sure that employees stay out of harm's way or the reach of that caught by hazard. Okay. And then always be ready to move right out of the way if necessary, if there's any type of failure. So maybe know where our next step is going to be just in case. Also, let's talk about safeguards a little bit, right, to prevent injuries or property damage. What are we talking about? Well, steel erection. What kind of work processes do we have going on? We have grinding going on, cutting going on, welding going on. These are all processes that we have going on during the steel erection stage, right? It could be we want to make sure that we have proper clothing. We want to make sure that we have long sleeve shirts, full length pants with no cuffs because of the hot work hazards that may be going on. Okay. And then also high top leather work boots, right? So we want to make sure that we're not wearing safety shoes, we're wearing safety boots. Okay. I tell employees all the time, especially for steel erection or anybody who's on the roof, I really want them in lace ups. Although then you may have to have a metal tarsal foot protector in place to make sure that no slag or anything gets into the laces if they're doing hot work. Okay, but I'd much prefer to have them in lace up boots so they have the adequate ankle protection and that the shoe is snug. Okay, that the boot is snug. Um, Most job sites, right, and plant operations, they require additional safety clothing to be worn, not just what we talked about. What are we talking about? Hard hats, right, or helmets, maybe some type of welding sleeves or aprons, let's say, chemical aprons. Could be goggles, right? It could be safety glasses. Okay, it could be possibly earplugs or ear muffs. Okay, so it could be any of that safety equipment, any of that PPE, and it could be some others as well. Also, the proper use of safety equipment, right, is determined by the specific hazard on the job. So basically, as we all know, not every area do we have all the same requirements for PPE. So the more significant the risk, basically OSHA tells our employer they have to conduct our employers must conduct a job hazard analysis. It may be done by us, it may be done by someone else, it's a subject matter expert within the company or outside of the organization. And basically, what are we talking about? Is that every area is determined to see what the significant risks are, and that's how PPE is allocated, right? Or maybe on a matrix, and that's how it's decided what we're going to be using in order to protect ourselves for that particular environment or that particular task. Um, in addition to that, also, what are we talking about, right? Let's use an example. Let's talk about eye protection, okay? It should be worn anytime we're doing any chipping, cutting, welding, and primarily, I tell people, it could be eye protection and it might also be face protection, okay? So things that we want to make sure is we want to make sure that that the following items that we have to consider before we start any type of steel erection, right? So loose clothing and accessories. We want to make sure that we don't wear loose clothing, right? We don't wear torn clothing, right? Or rings or jewelry when we're doing any type of steel erection. Okay, clothing and accessories. What happens if they don't fit tightly? Hey, they could get caught in some type of moving machinery, right? Also, clothing materials. Because of flying parts, sparks, okay, intense heat, slag from cutting, grinding, welding activities. Clothing it can't be made out of polyester or other synthetic fibers. Making sure that we're wearing preferably FR clothing, but if it's not a requirement to have a fire resistant rated clothing on, and then at a minimum have something that is made out of, let's say, cotton, right, is made out of a wool blend. And so something like that that would be more resistant to sparks and be less flammable risk while we're wearing it. Also, not having anything with cuffs or flaps on it, right? So, basically wearing a perfect example would be wearing a shirt with long sleeves, right, to protect our upper body and our arms. A pair of full length pants with no cuffs, okay, that would shield the lower half of the body. Okay, so basically, right, as far as the legs, cuffless pants should hang straight through the leg, right, and over the top of the work boots. So it's not acceptable to have an employee with tucked in work boots when they're doing steel erection or any type of hot work or chemical or hazard work around chemical hazards. I tell employees all the time, best thing to do is always have those pant legs pulled out over the boot itself. Okay, pants with cuffs have to be avoided. We can't wear them. Okay, when it comes to hot work or steel erection. Also, why? Because the cuffs can catch any type of sparks or slag, just like laces could, right? In a lace up boot. Okay, and it could start a fire or significantly injure the employee. Also, uh, pockets on shirt have to be covered with a flap, or they have to not have a pocket at all. So we cannot have a pocket without a flap, and we cannot have a pocket with a flap that's tucked in. Okay, it's going to have to be tucked out and over so that no fire hazards enter that pocket. Okay, and it'll keep any type of flying debris or sparks or anything else, any other loose materials like that from getting into the shirt. Also, long sleeves and a closed shirt collar, right, to make sure that it's tightened up as much as possible. And then also worn clothing, right? Clothing, the clothing can't be worn out. It can't be frayed. Why? It's another significant of a fire or a risk. Okay. Also, footwear. What are we looking at? Well, we know footwear is going to be basically our leather boots, right? Steel toe and in good shape. Okay. Especially if we're doing arc welding, making sure, and we shouldn't ever have the steel caps exposed because they have a significant risk of electrical hazards and conductivity. And bottom line, it violates the ANSI standard, folks. That cap, we either have to have the boot with a new cap on it, or the initial cap that came with it must be in good shape. Okay. Also, headgear, right? We have to make sure that if we wear any type of headgear, are we hard cap welding or soft cap welding? If we're soft cap welding, we want to make sure that cap is made out of some type of material like cotton or preferably wool, right? Same thing to have less of a risk of a hazard. If there are very few locations now that allow welders to weld with a soft cap, but if a soft cap is used, well, then that soft cap's going to you have to make sure that employee, when they leave that area, or if there's overhead hazard, they put that hard hat back on. Okay. Another thing, folks, is I would like to tell you this is let me go to the internet and let's talk about these caps for a minute, right? We know that we often have welders with hard hats, right? That what'll happen is we normally don't use a full brim. We use a quarter brim, one of these quarter brims. And what happens is the hat is turned around. As the ANSI standard says that as long, and the manufacturer says that as long as the ratchet setup will flip around and comfortably fit or fit just like it would have right side when the bill's to the front, it's acceptable to wear. Okay, so as long as this ratchet strap, which it should be made to turn around both ways. But I'll tell you where the significant hazard comes in with hard cap welding like this is that once that employee leaves that area, now that employee has has a risk because they have this hard hat on, and this is the front of the bill now. This is the front. Now they don't have over the eye protection when they are welding. Okay, so what happens is perfect example right here. Look at the employee's glasses and look at his hard hat. When the welding hood comes off, right, or here, that's fine. But once they pull it off, now we've lost the overhead bill protection to go underneath the top of over the top of the front of the glasses. Okay, so just keep that in mind. Okay, folks, so that it's one of those things where it's almost like the necessary evil. And then here's examples, right, of soft caps that we may be talking about and making sure that they're rated for hot work. Okay, but like I said, there's always a significant risk with that hard cap welding when that employee is going to use that walk around the rest of that facility work site with a hard hat on and the bill's not facing the front of the hard hat. Okay, it's a big challenge, folks. Okay, so let me keep on going, and then we're going to stop in just the next couple of minutes. Okay, folks. Um, in addition to you know to that, let's go ahead and talk a little bit about safeguards and to prevent injury and illness. Okay. So what are we talking about? Following items have to be considered right before we start any type of steel erection activities, and that's what we just finished closing out. The last thing we had left on that was gloves, right? So what are we talking about, right? That iron workers, they have to have when they're handling metal objects, we have to give them some hand protection. Items that we want to make sure that we keep in mind is gloves that have adequate protection that aren't worn out. Also, how much resistance can we give them or protection against impact, right? But they have to be rated in order to minimize the risk of fire or injury to the employee due to heat. Okay, so we would need to make sure that we have the right rated gloves. What's the easiest way to know that we have the right rated gloves for welding purpose? Check the manufacturer specs on those gloves. If they say that they're acceptable for welding and that they say they're acceptable either for gas and or for electric welding, then we know we can use them. Okay, so fall back on the manufacturer, fall back on your supplier, folks, so that you can go ahead and get make sure that an employee is appropriately protected. Okay, and then what we're going to do is let's go ahead and stop right there since we're doing PPE. We're going to stop at the bottom of page 3, and let's take a break, folks. Let's take I've got 7:28, so let's go ahead and break for the next 12 minutes. And then when we come back, we're going to kick it off with controlled deck zones. And we're going to go ahead and roll through the end of this chapter. Okay, there's not much left in it. So we're going to go ahead and roll through the end of the chapter, folks. And then and we'll see how the night takes us. We may stop there. We may try to get one more, just depending on what kind of time we're making. Okay, so let's take 12 minutes. And I'll see you back at that time. My clock right now says 7:28. So at 7:40, we'll kick it back off. Okay, thank you. All righty, folks, we're back in now, okay? So we're going to go ahead and keep it going now. We're at module 6, page 3 now, and we're going to talk about controlled deck gain zones on the bottom of the right-hand side. We're going to go ahead and push through for about the next hour, folks, okay? We'll be shutting it down again right around the same time that we have been, right around 10 minutes to 9, okay? So this session will take maybe right around an hour. It might even take a little bit less, just depending on whether we get into 7 or not, okay? Just trying to, like most of you know, we're trying to stop it at the end of each module, but it's kind of tough, okay? All right. So control deck zones, right? They can be established for work areas, and it's going to be at least 15 feet tall, but no more than 30 feet to the next lower level. So what does that mean? That basically means that we can only go two additional levels, right? So let me show you what I'm talking about. Let me go ahead and bring you. I think I've showed you this once before, but I'll show you again. Let's see. Okay, 1 second, folks. I lost. I can't get out of the screen for some reason. So give me one. Sorry about that. Okay, there we go. Okay, so let me go to the end of this PowerPoint. I don't know what happened there, so sorry about that. Okay, so here we go, folks. This is what I'm talking about right here. Is a controlled deck zone. It's going to be at least 15 feet tall and no more than 30 to the next lower fall. Okay, so if this is, let's say this is a parking garage being built, right, and it's maybe 10 foot over 10 foot over 10 foot, 30 feet. If our fall from here down to the ground is greater than 30 feet or to the next whatever this next lower surface is, we cannot use a controlled decking zone. Okay, we would at that point have to use either some type of safety net, which a safety net also, we cannot have a fall greater than 30 feet in a safety net, or obviously the next option is going to be the guardrails or some type of personal fall arrest. Okay, so that's what basically the controlled deck zone is telling us at the bottom of page 3 on module 6. Okay, so controlled deck zone, I'm moving on to page 4 now. Controlled deck zone, or CDZ, is a substitute for fall protection, right? Where decking is initially being installed. Only workers trained for CDZs are allowed to work in that area. Okay, so it would only be roofers or whoever's doing the decking work. The controlled deck zone it has to be clearly marked, and the zones can be no wider than 90 feet, okay, and 90 feet deep from any leading edge. So that's going to be the full width is going to be 90 feet. It's going to be the most of the full width, okay, or depth. All openings in the floor or the roofs have to be covered with materials capable of supporting twice the weight of the worker, and equipment that's going to be placed on top of it. So what am I talking about now? Let's say for some reason we have a skylight here, right, on the surface, or we have some type of opening on the surface. We're gonna have to cover any type of areas like that where there's no fall hazard going into it. Okay, or we're gonna have to guardrail, or we're gonna have to go ahead and guardrail around it. Like, let's say if this is an open right here skylight or something, we'd have to guardrail around it. Okay. The covers have to be painted with high visibility paint, and they have to be marked with the word either hole or cover. Okay. And then, we have to provide warning of the hazard. Basically, that's why. OSHA also requires that training be provided on the proper use of each of the fall protection devices used at the work site. So if we're using retractables, we got to be trained on retractables. If we're using controlled deck zones, we have to be trained on controlled deck zones. If we're using shock absorbers and lanyards, we have to be trained on shock absorbers and lanyards. So whatever the hazard is or whatever the PPE is, we're going to have to be trained on it for that particular work site, okay? Or for that particular type of task, excuse me. Warning signs. We have to observe all warning signs, right? They have to be visible. We have to use tools and equipment the way they're prescribed or they're required, recommended to be used. We have to maintain good housekeeping. We have to be conscious of employee safety, right? Because we know it's going to greatly reduce any type of hazard, so we can anticipate the hazards. Therefore, we can implement the correct controls in place, right? We also have to comply with OSHA requirements for head and foot protection and hard hat zones. We have to locate and observe all warning and accident prevention signs and confine movements only to those work areas, right? So all the signs are going to have to be visible and accessible to employees. Also, we have to only enter restricted areas with permission from the superintendent or the foreman. So we have to be authorized if we're going to be within that fall protective area. Okay. We have to keep out from under the raised loads unless we have duties that are going to be requiring us to be there, like a rigger or something like that, or somebody receiving a load. We also have to keep out from under raised loads, like we're talking about. Never ride a load or crane hook. Okay, we can't ever ride a load or a crane hook at all. Also, walk around the scaffolding areas, right? If it's necessary to work around raised platforms, we have to be sure that the work site is covered and protected. So we don't want to be walking under scaffolds unless it's being made for traffic through underneath the scaffold. Okay, easiest way to tell is if we're having to walk over any type of cross members, any type of bearers, or anything else like that. If you have to lift your legs to get underneath a scaffold, you're not supposed to be under there. Okay, it's going to have to be open access to be able to easily traffic through, and it's going to have to be decked from on top and toe guards in order to protect us down below. Okay, and then we're still going to be in a hard hat zone. Also, let's talk about contaminated and dangerous areas. We have to also check the area for immediate hazards, right, related to our health. We also have to make sure that we keep any hazardous or dangerous materials out of the work area, okay, or any equipment. We have to keep track of any type of exposure time and spend as little time in those areas as possible. What kind of hazards are we talking about? We're talking about air contaminants. We're talking about asbestos. We're talking about coal tar pitch volatiles, right? Or volatile organic compounds, also VOCs you'll hear sometimes. We're also talking about occupational noise, ionizing radiation, non-ionizing radiation. Those are just a few examples of the hazards that we have to keep track of. Silica, okay, in areas that we're gonna be working around. Lead. So anytime we're gonna be working around an area that may not be safe, they have to monitor and track the amount of time that we're exposed and not exposed, excuse me, that we're in that area and provide the adequate PPE or engineer controls or administrative controls in order to either minimize or eliminate the risk. Okay. Also, hazardous materials. We have to check the job site locations, right, for highly flammable materials, volatile materials, corrosives, explosives, the hazard materials that any type of employee may come into contact with. Perfect example is compressed gases, right? Acetylene, oxygen, propane. Remember, folks, acetylene is often a significant risk in a steel erection job because acetylene is being used with oxygen as a fuel and a gas setup in order to do welding. Okay, so we want to make sure that we keep those hazards either minimal or that we try to control them as best as possible. Also, hydrogen. It could be nitrous oxide as well, gasoline, diesel, any other hazard. What do we do? What's the best way to protect ourselves? Check out the safety data sheet, right? Make sure that we check out the safety data sheet, how to safely be able to use, store, and work around that chemical, and also to see if any type of PPE is required for us to work around that chemical as well. And then, of course, we also want to protect from fallen objects and flying objects as well. Things that we know that they can range from minor abrasions, right, to concussions, blindness, or death. You know, things that we want to safeguard around and practices we follow are really simple, right? So let's go through the list. Practices like not walking under a load, always wearing a hard hat, using toe board screens, guardrails to prevent fallen objects from striking those below. We'll talk about that in a moment. I'm going to show you how to pull that up again in the OSHA standards, okay? Also using safety glasses, goggles, face shields around machines or tools that might have flying particles or flying projectiles. Also inspect tools to ensure that the protective guards are in good shape. Also make sure all the safety devices are in good shape. Not using any powder actuated tools unless we're qualified and properly trained to do so. Powder actuated tools require their own certification or designation by the employer. So I'm going to show you that as well in just a second. Also inspecting tools to ensure that, like we said, the protective the protective guards in good condition. Excuse me, I repeated that. Avoiding working underneath loose loads being moved, right? Also barricading hazardous areas and posting warning signs as well, respecting warning signs. Inspecting cranes, hoists to see that all the components like wire rope, lifting hooks, any type of slings or shackles, any chains are in good shape and good condition. Also, not exceeding the lifting capacity of the crane, the hoist, or any type of slings. Okay. As a matter of fact, not only are we going to want to stay under the lifting capacities, we're going to want to stay under 75% of the lifting capacity. If we happen to exceed 75% of the lifting capacity of a crane, of any type of hoist or slings, if we use two cranes to lift one unit, It's called a tandem lift. If we do any of those, we're going to be going into a critical lift plan. Okay, anytime we exceed 75% of the rated capacity of the slings, the hoist of the crane, and anytime we're using more than one crane or more than one hoist to lift up one piece of equipment, okay, or material. Also, do not use buckets or pails, right, to hoist up materials. What are we going to use? We're going to use bolt bags, right, designed for that type of work. So we don't want to tie a bucket or some type of a pail to, let's say, a hoisting hook or something like that. We want to use a bolt bag that's designed for that particular type of process. Okay. Also, securing tools using tool holders and lanyards. Also, securing loose materials to prevent them from falling on anyone below. Okay, so let me show you a couple of things really quickly, folks, that we were just talking about. So let's talk about piled material, right? I've showed you this a couple times already. I'm going to go back to it again. I'm going to Google, and we're going to try, first we're going to do toe boards in Google, and then we're going to do toe boards, in construction, and next we're going to do toe boards in general industry. And we're gonna see where they are, where we're required to make sure that we're either meshing or solid wood, solid panels for piled material. Okay, so I'm doing OSHA 1926 for construction, toe boards, and I'm doing the word piled for material. Okay, so when I come here now I'm word searching. I'm word searching for the word piled because I'm used to looking for it. Let's see. It's going to be right here in the scaffold standard, I believe is where it's going to be. Okay, so here you go, right here, where tools, materials, or equipment are piled to a height higher than the top edge of the toe board, paneling or screening extending from the toe board, right, or the platform to the top of the guardrail, have to be erected, right, in order to protect employees down below. So there you go, folks. If we have any type of material piled on that scaffold, we got to go ahead and we have to go ahead and either mesh off or use some type of paneling or something in order to protect employees from down below from items falling through off of that elevated work surface. Okay, that's 1926. Now I'm going to 1910. I'm doing the same thing, and now I'm going to walking and working surfaces. Now what are we talking about? Like fixed catwalks, items like that, right? And let me see if this is where it is. I don't recall where it is. And I don't recall why I'm not finding it. I remember having to look for it a little bit harder the last time in general industry. I'll find it because I know we have a standard in general industry as well for the same thing for toe boards. Okay, so let me find it, folks, and then I'll go ahead and supplement that as well. And let's see, it might be here. Let me see if it's in paper mills maybe. Yeah, I'm gonna look for it. I apologize about that. I remember we had some issues finding it the last time as well. And then let's try this one more thing. Here we go. Actually, of all things, I found my post in on LinkedIn. All right, and there you go, folks. There's a standard number, 1910 4E. And I don't know why we couldn't see it. We couldn't find it in the standard. But where materials are piled to the higher standard than a toe board, right? And then we have to do the same thing. Now we have to have paneling. It doesn't even give us the option to mesh. Okay, but there you go, folks. There's the 1910 standard for general industry. Okay, and then there's your 1926 451 standard for construction, which is the one we just looked at. Okay, so sorry about that. Okay, great. All right, so that's the first one, and now let me show you the second one. The second one that we talked about was powder actuated tools. And let's do OSHA powder actuated tools. That's the maritime one. I want to find the okay, so here you go. This is the OSHA letter of opinion, folks. Okay, and this is what it's saying, right? There you go. There's your construction standards right there on them that are referenced, and this is what it's basically saying, is that powder actuated tools, right, used in construction are governed by, this is the standard number that they're governed by. And basically what's it saying is this, that only employees who've been trained in the operation of the particular tool in use is allowed to use that power actuated tool. Okay, so what are we talking about normally when we're talking about powder actuated tools, folks? Normally we're talking about ram sets, okay? Normally talking about ram sets. So here you go. For anybody who's not familiar with what a ram set is, here's all different ones. And basically what we use them for most of the time is nailing into concrete or hardwood or something like that. You'll notice something like that in residential construction a lot of times, and some commercial, either putting studs into a wall, could be a cinder block wall, could be another harder surface wall, and then also into the ground as well. Okay, they have different types. Some of them you can hit with a hammer on the top, like this one right here. And what happens is they're all like a gun. They have a firing pin in them. They take a shell, a blank, and they also have a projectile. Okay, so there you go. There's a 22 caliber shell. And the shells also, just so you know, folks, all the shells come at different ratings as well. Okay, so they come in different strengths. So right here is a perfect example. If you look at it, ram set strength right here. So depending on what the power level is. So who tells us what the power level is? The manufacturer. You go to Ramset's website, right, or they'll tell you on the box, or they'll tell you on the nail gun, and they'll tell you what you're drilling, what you're nailing into, and they'll tell you what size nail to use often sometimes, or sometimes that's usually regulated by depending on what we're nailing, what stock, how thick it is. But they'll tell us what power to use for the depth that we want to go. Okay, so we need to make sure, again, follow the manufacturer specs, folks. Okay, just like a powered industrial truck, we training employees to the manual. I would highly recommend that with ram sets, the best resource you're going to have with any of these is training employees to the depth of what the hazard is. Okay, here's an example of just different. This seems like an overseas one, but look at all the different types of nail types that you have. Go to your local Home Depot, folks. You'll see exactly what I'm talking about. Okay, go to Home Depot or Lowe's. Okay, all right, great. Okay, so let's move on, folks. So we're talking about flying objects. Now let's talk about rigging safety a little bit. And I'm at 1.2.6. Just give me 1 second. Sorry about that. I'm having some issues with this PowerPoint, I think, tonight. Okay, so don't worry about what you see on the screen, folks. I'm just trying to actually get to this screen right here. Okay, I'm going straight out the book, just so you know. I'm just having some issues with the PowerPoints, and I'm actually just trying to leave something where I can actually see the screen. Okay, so rigging safety, right? What are we talking about? Rigging safety. We're looking at safe rigging and hoisting, right, of steel members. That we know that that's an essential part of steel erection, right? We have to fly that iron or get that iron into place somehow. So items that we want to be cautious of, right? The rigging safety. First of all, it's extremely complicated. It can be extremely complicated. It can be very dangerous, right? Because we're lifting heavy material through the air. Okay. Some rigging operations require cranes. Okay. And then some other ones may use types of heavy equipment, right? Front end loaders, skid steers, items like that, right? Doing vertical lifts. We may be using power lifts in place as well. So depending on the type of equipment that we're using. Also, and the type of rigging that we're using. Also, tool safety, specific rules, right? For hand and power tools. We have to, we've talked about power tools before, and, as you'll see, we'll continue to talk about them as well. Also, we have to remember certain rules, right? First of all, respecting those power tools, right? Having that positive attitude, respecting the power tools, using the right tool for the right job. We hear that over and over and over again, right? Also, requiring knowledge and capabilities of tools and understanding how each tool is used and how it's supposed to be used. Also, assuring that we use tool holders and lanyards when we're working at elevations. A lot of times now you hear about drops programs. Okay, dropped object safety, right? And they're calling it drops programs. And basically it's tying off tools to make sure that when tools are being used at elevated work surfaces, if they fall, they'll be suspended, as opposed to employees being dropped on employees. Okay. Um, so let's move on to page 6, and items that we can do, right? Our proper care tools, okay, that we know is going to prolong their use, right? And it may prolong the worker's health and safety as well. Caring about tools properly and making sure that we do our systems and our checks, right? Perfect example is, you know, making sure that tools are free of grease and oil before we use them, in order to prevent any type of slipping out of our hands. Make sure the tool doesn't malfunction. Okay, properly lubricated is one thing. Being slippery or greasy is different, as another thing. Also, tools being properly depressed, right, free of defects, and sharpened where appropriate. So if we're using a knife, right, or if we're using a particular piece of equipment where something's got to be sharp, we want it to be sharp. In addition to that, also electrical hand tools, right, equipped with automatic shut-off controls. So basically having those dead mens out of them, right, where they can't leave a grinder on. It's got to be manually held, or the grinder will stop by itself. Portable electric saws and drills, properly guarded and grounded as well. Okay. And then damaged tools and repaired before use, right? Making sure the tools are either repaired or pulled or kept out of service. Never performing any welding on any type of tools. If the tool's damaged and the new tool needs to be pulled out of service, pull it out of service. Let's try not to fix it ourselves. Also, for rules for carrying and for the safe use of power tools, right? It's going to include not attempting to operate any power tool without being properly trained on that particular tool, right? That's what we've been talking about most of this session. In addition to that, also, um, always wearing appropriate safety equipment, right? Protective clothing, or the correct PPE. If we need to wear safety glasses, right, or close-fitting clothes that can't become caught in moving parts. We may be required to roll up sleeves or tuck in our shirts. Okay, tie back long hair. So depending on what the practices are at the facility, never leaving a power tool energized and unattended. Assume a safe and comfortable position before we start using a power tool. Ergonomics is important, but also tool safety, right? It falls into both categories. Don't distract others, and don't let anybody distract you while you're using a power tool. Be sure that any electrical tools is properly grounded before we use it, or make sure it's double insulated. Be sure that power is not connected before performing any type of maintenance or changing any accessories. First thing we want to do is go ahead and unplug that tool, right? Also, don't use any dull or broken accessories as well. Use power tools for the way that we're intended to use, the way the manufacturer recommends or requires that we use them. Don't use any power tool with the guards or safety devices that have been removed or damaged. Use the proper extension cord that's sufficient size to make sure that the particular tool is being used. Someone and I recently had a discussion about this with powered industrial trucks. They were charging a truck and they were using a good cord. They were using a 12 gauge cord. The cord was much thicker than what the cord was on that powered industrial truck, on that forklift, okay? Fork truck, actually. So just keep those items in mind as well. Also, becoming familiar with the correct operation and adjustments, right, for any power tools that before we need to use them. Perfect example of that is circular saws and table saws. Perfect example. Um, Also, making sure that we have adequate ventilation, right, before operating any type of gas-powered tools. It could be gas, it could be propane, okay, to make sure that we're not getting any carbon monoxide hazards in there, or LEL hazards in there. Also, keeping a fire extinguisher nearby when we're filling, operating gas-powered equipment, right? And then also storing tools properly when they're not in use. So making sure that everything's got a safe place where the tool's not being damaged or affected, and it won't damage or affect us if it's not in use. Okay. And then, of course, welding safety, right? What are we talking about? We're talking about welding and cupping operations. We know it's common in the workplace, especially around steel erection. So there's some basic safety that we're going to follow at all times, right? We're going to make sure that, if we need any particular type of eye protection, we're going to wear it. Not only safety glasses, it may be shields like we're talking about. It may be a welding hood, just depending on what's required. Okay. In addition to that, also is wearing safety glasses right underneath those helmets as well, to make sure if it's just a shield, depending if whether it's fully encapsulated or not. Also, precautions that must be taken for spark containment, right? Any workers below the welding area that have to be protected. What are we talking about? Any type of shielding, blanketing, right? That we may be doing down below. Also, additional appropriate PPE that may need to be worn while we're welding, like welding leather gloves, right, or gauntlet gloves. A lot of times you hear them called welding aprons, right, sleeves, jackets. Uh, depending on the type of glove, and then helmets and shields as well. And then we also have to be cautious of gases, dust, fumes that might be produced during a welding operation, okay? Because we know it can be hazardous to us as well, right? And we need to make sure that we're aware of those hazards and the appropriate precautions we have to take. Welding should only be done in well ventilated areas. If it's not a well ventilated area, we need to we need to manually ventilate, right? Or we need to go ahead and put ventilation in, temporary ventilation in. We need to avoid inhaling welding fumes and smoke. It's like I tell a lot of people. Biggest thing is we don't want the fan blowing on the welder. We want to pull it away from the welder, so that therefore um, it's pulling, extracting the welding fumes away from us. Okay, if we're doing welding, or if we're observing a welder. Also avoid that way an employee, like we said, a welder can avoid inhaling those fumes or those vapors. Okay, or smoke. Also, respirators, they may be needed. If they're needed, we need to make sure that that employee has been medically evaluated, pulmonary tested, and then ultimately fit tested every year. That fit test is going to be every year. And additional precautions, right, as necessary, depending on the type of equipment that we're using, okay, and depending on the metals that we're burning on, you know. Um, could there possibly be any type of metals that are galvanized, right? Or any type of epoxy paints? Perfect example are sealers. Okay, and then hot work permits, we have to obtain them. We have to go and clean, and go ahead and get them up and ready, especially if there's any risk of welding or doing any hot work around a flammable. Okay, and then crane safety precautions. What are we talking about? Cranes, right? Um, and a potential danger that we need to make sure that we minimize. First step in preventing is knowing how serious the accident can be, right? How, what significant risk can happen. And in certain cases, we know accidents, especially when it comes to cranes, it could have been prevented. Okay, either by repositioning the employee or by adequately training the operators, and the operators adequately following the safety precautions. We want to make sure that we do things and assure that nobody walks under raised loads, okay, unless they're instructed to be in that area. And who's that going to be? That's probably going to be like we said, somebody receiving a load or some type of qualified rigger. In addition to that, we also want to make sure that we're always aware of the position of the load when we're hooking on it, arranging loads, right, or moving loads across construction sites. We want to treat, all lifting operations as if the equipment failure could occur, right? What if? What if that equipment were to fall off that hook? What if that hook were to fail? Who's going to be in harm's way? So these are situations that we want to take into consideration. It's kind of like what if, right? Or failure mode evaluation analysis. We're basically preparing for the fall so we know how to better protect the employees. Also keeping hands out of pinch points. Okay. When assisting with hooks, either hooking or unhooking, want to make sure that we keep our hands out of pinch points, that the operator's not starting to operate and pull on that running line. In addition to that, do not use the crane to pull a sling out from under a load. Right. We want to make sure that we manually pull it out. Um, Also, not always standing clear of the rear of the rotating equipment. Look down at figure 5 at the back. Pinch point, right? Employees being struck by either the counterweights on the crane or the back of the superstructure of the crane. Basically, superstructure is where you see where the cab is. That whole unit is what we're talking about, right? So making sure that employees aren't harmed. Um, in addition to that, also keeping clear power lines like we talked about, minimum 10 feet away, sometimes even 20 if it's over 50,000 volts or we're not certain. Making sure that we talk to the utility companies to find out where all overhead and underground power utilities are located. Okay, make sure there's no caverns or coffer dams or anything else underneath where we're going to be, or vaults, or we're going to be operating a crane on. Okay, assure those ground conditions, and then learn the crane signals, especially the emergency stop signal. That's really imperative that people know the emergency stop signal. I think all employees in that area should be trained on it. Okay. Further than that is if a crane operator always has the right to not initiate and not take a load, but also OSHA requires that a crane operator always stop work regardless of who calls a stop on a crane. Okay, in the crane area. Um, learn the crane signals if possible, right? Like we were just talking about. And then material handling and storage. I'm over at page 7 now. I'm over on page 7, 1.210. Okay, 1.210. So what are we looking at? Material handling and storage, right? So we know injuries could occur. And I'm sorry, folks, let me go back. Look at your 2 different pinch points, perfect examples on your left-hand side of page 7. It could be pinch points between the rigging and the load. It also could be pinch points between the hook and the rigging at the top where they're not showing it, and then at the bottom, right, where an employee may watch where you put your hand placement when a load's being put down. You're not going to be able to physically manipulate that load. Okay, so watch where your hand and foot positioning is and your body positioning. And then going back to material handling and storage now, we know that there could be significant injuries that occur when we're manually handling equipment or when we're using mechanical or non-mechanical equipment. Okay, so most non-mechanized moving, what are we talking about? Stacking, loading, right? Unloading. Okay, tasks that are performed by experienced craft workers. We want to make sure that the employees are adequately trained. In many cases, what are we looking at? Is we're looking at that they're trainees. So we want to make sure that trainees are adequately experienced, where they gain experience, and we adequately educate them to make sure that we can help prevent like strains, sprains, right, fractures, crushing, injuries that could be minimized by proper knowledge, right, safe lifting and handling techniques, basically good ergonomic practices, and then situational awareness of where we're putting our body parts as well. Okay, respecting the weight, the load of the weight. Okay, general points, right, to keep in mind when we're handling moving construction materials is these are things that we want to keep in mind. Expect materials, right, for any type of slivers or for any type of rough or sharp edges. We also want to determine the weight of the load before we attempt to move it. We really, whether it's mechanical or whether it's manually, we need to know what that piece of material or equipment weighs. Know our own capacity for lifting objects. Some employees may lift 50 pounds easily. Some employees may not. So your body, and we have to advise, right? Or we have to be cautious maybe of employees that have a predisposed to maybe a back injury, muscle pull, or whatever the case is, or just may not have the same physical strength as some other employees. Also, be sure that the pathway is free of obstacles, keeping our hands free of grease or oils as well, so we can have a firm grip on objects before we move them, being careful of where we put our fingers, our hand and finger placement, use good body mechanics, use gloves when we're handling sharp edged materials. Often nowadays, we're using gloves when we're using any type of lifting. Get help with the load if it's too large or too heavy. Just because the load is not heavy, it could be large or long or awkward. We just want to keep that in mind, okay? Because if it's something that we can help prevent, we want to try to help prevent that injury from happening. Okay. So those are all the tips that are in there for Module 6. So what I want to do is let's go ahead, folks, and let's go ahead and move on to Module 7. Okay. So you'll see there's your questions on there. Could you do me a favor, folks? Anybody who's on the line right now, let me know. I know we sent the the end of chapter quizzes for the field safety book. Can you let me know and send me a message if you got them for the field safety book already, and if you got them for the safety technology book? Just trying to figure out who's got what. Okay, good. Okay. All right, great. Well, give me 1 second, folks, and then we're going to go ahead and kick off. We're going to Module 7, page 1. Okay, just give me 1 moment. Okay, so let's talk about talk a little bit about cranes. Okay, anti-tube blocking device. I'm going to show you what it is, and basically this is what it does: is it provides a warning, right, and it prevents tube blocking from occurring. And what's tube blocking? It's when the lower block, load block, and the hook come into contact with the upper load block. I'm going to show you there's an illustration of it in the book, and if not, I'll show you on the internet if necessary as well. Okay. Um, and so basically, it's whenever like I said, the load block or the hook come into contact with the upper hook, with the upper block. Okay, in order to prevent from the machine malfunctioning or pulling the cable out. Okay, or busting the cable, and the likely result where the failure of the rope. That's what we're talking about. It was going to happen, right? Also, equipment maintenance. What are we talking about? Care and cleaning, inspecting, and proper use of that machinery. Equipment operator, that's obviously, it's a skilled person that's skilled. And not only are they going to be skilled, now they're going to have to be certified. Okay. So that's going to be the new requirement, is that the operators are going to have to be certified as well. Starting November 10th, 2017, operators will have to be certified for construction cranes. Okay. And then you see hydraulic, right? What are we talking about? Tools and equipment that are powered by liquid under pressure. Normally it's hydraulic fluid. It's a thicker oil is what it is. Okay, hydrocarbon. And then momentum, right? The physical force that it takes in order to move an object, right? Or if an object's already in movement, that it takes to stop an object. Okay. So let's talk about a few of these things. So, basically, just remember this, right? Let's talk about motorized equipment on a job site. What kind of job sites are we talking about? It could be civil, right? Residential, industrial. It could be mining. It could be maritime, snow and ice control operations. It could be maintaining road surfaces like patching potholes, cracks, raising depressed concrete, resurfacing asphalt, painting stripes, sweeping highways. This is all the different times that we'll be using some type of motorized equipment. Okay. In addition to that, it might be loading, lashing, or unloading equipment and materials. Loading or lashing, folks, anybody who's not familiar with what lashing is, what it is basically it's ratchet strapping something down. So let me show you really quickly, okay? I've got a presentation. If I can't find it right away, let me just look up vehicle lashing, the easiest way. That's what I'm talking about right there. Just tying it down with ratchet straps, okay? And that's where we're lashing the piece of that equipment down to something, okay? It could be in a vessel, it could be in a vehicle, whatever the case is. We basically, what do we call it? Tying it down, right? So that's all lashing is for anybody who needs to know. Okay, and then minor equipment changes and repair, maintenance and repair, also transporting equipment over public highways. These are all different types of when we'd use it, right? So check out the next page. Look at all the different types of industrial powered equipment that we're talking about now on the next page. So on page 2 and 3, you see, obviously, you'll see excavator on page, you see your excavator on page 2, and then look at your right-hand side, page 3, you see your bulldozer, you see your articulating off-road dump truck. You also see basically why articulating, because it joins in the middle, right? Almost like an 18-wheeler, and it allows that dump truck to maneuver a little bit better. Also, we have an excavator again. We have our backhoe loader as well. We have our motor grader there. And then you also have your skid steer, okay? So just all different types of bobcat, skid steer, depending on what you call it, okay? So all different types of heavy equipment, right? So construction workers, right? What could they be expected to operate in the workplace? Well, it depends. They could be expected to operate any of these at a minimum. And all this equipment, it's going to severely change in size, weight, capacity, how it operates. Okay, centers of gravity. So items that we're talking about, right? Trucks, cranes, compact equipment, backhoe loaders. So we're talking about scrapers, bulldozers, excavators, motor graders. Could be street graders, street rollers, skid steers. Okay, forklifts. Concrete paving equipment, right? Concrete plant equipment, asphalt plant equipment. It could be pug mill mixers. It could be fine grade trimmers, cold milling machines, okay, stabilizers. It could be trench and rock saws. So, I mean, all kinds of different equipment that employees might be needed to operate. Now, this is one thing I want you to remember is that any piece of equipment that you see here that an employee must operate, employee must be, let's go back to the whole powered industrial truck standard, right? Employee must be formal trained, right? Basically knowledge trained. They have to be practically trained, and then they have to be evaluated on that particular type of equipment, not that brand, that type. So let's say, let me use an example, bulldozer. As long as they trained on a bulldozer, it doesn't matter if it's a Deere, a Komatsu, okay, a Caterpillar. It doesn't matter as long as it's not a significant difference, okay? So just keep that in mind, okay? And folks, look, this is where in your professional career in your lifetime, you really got to ask yourself: are you a cat person or are you a deer person? So, are you caterpillar or are you deer? Anybody out there got an opinion on that? We got one deer, one cat, two cat, okay, three cat. There you go, folks. So, just you got some people that are really hooked on cats, some people that are really hooked on deer, and then you got some Komatsu people out there. You got a different link belt, different types of equipment. Okay, so all right, so let's go ahead and move on, folks. So let's see, I'm moving on to page 4 now. On module, what are we? Module 7. Okay, so we want to make sure that we have general safety rules, right, to make sure that we protect employees' health and safety. What are we talking about? Anytime we're working in areas, right, with these types of equipment, first of all, be alert. Okay, we've got to watch out for any type of moving equipment, right? Whether it's our heavy equipment, whether it's a regular over-the-road equipment, whether it's people on foot, whatever the case is, right? Employees on foot or the public on foot. Also using spotters, right, to guide equipment or loads whenever possible. Especially if we have blind spots, we must use a spotter, okay? Also construction equipment. We know it's heavy, right? It usually carries large loads. So what happens is that we tend to have a good bit of momentum. We can't easily stop, and we can't stop short. Okay, so keep that in mind, right? Because we don't want to risk that equipment. We don't want to possibly harm somebody. So it's items that we want to, it's issues that we want to make sure that we help protect ourselves and everyone around us as much as possible. Okay, so take your time. Move slowly, right? Start slowly, end slowly. Okay. Um, Also, making sure that you never position between a moving object, right, and something that's immovable, or even two moving objects for that fact. Also, some heavy equipment is designed to carry heavy loads overhead, right? Never stand under the raised load. Objects could fall, right? They could suddenly, the vehicle could lose pressure, hydraulic pressure for some reason. The boom could collapse. So there's all these different reasons why we don't want to be under where the load is. If it's on any type of rigging or slings or anything, wire rope, a chain, it could fail. Okay. Also, use retaining guards, right, or safety devices on all equipment. So if we can secure a load before moving it, in order to minimize how much it's going to move around, let's try to reduce that momentum. Okay. Also, report any type of defective equipment, material, tools, and also let's lock it out and tag it out of service if we need to. Okay, disconnect that power, right, and tag out that equipment. But not only tag it out, put why it's tagged out, and make sure you take that key out of it also. Okay. Also, use properly fitted wrenches on nuts and bolts. We don't want to use vice grips or regular pliers. We want to use fitted sockets or fitted wrenches. Okay, and that way we have less risk of stripping any type of fasteners on that vehicle. Also, keep our work area clear of scraps and litter. uh, Dispose of combustible materials properly, right? Keep them out of the way as much as possible. Clean up any spilled liquids immediately, right? Any risk of fire, explosivity, okay, toxicity. We want to make sure we get all that cleaned up. Also, store oily rags in self-closing metal containers so that they don't spontaneously combust. Never using compressed air to clean ourselves off or our clothing, especially never using compressed air, period, and especially never using compressed oxygen to blow anything down. Okay, making sure all others on the site, right, are safe a distance from equipment. Okay, use traffic control devices where we need it. I think last week we were talking about TTC, right? Temporary traffic controls is what it's called. TTC. What are we talking about? All of those. All of those barricades you see down in figure 3, and then the cones in figure 2. Okay, or I'm sorry, both of them are figure 3 actually. Also, personal safety, right? It's important, as site safety, right? We need to make sure that we watch our actions because we don't want anyone getting hurt. What are we talking about? Like wear close-fitting clothing again, right? That may not get caught up. Tie back and secure any long hair underneath, and hard hat before operating equipment again. Wearing safety glasses, suitable hard hats, goggles, hearing protection, respiratory equipment. Depending on what we need, you'll see all the PPE on your right-hand side on page 5, and then removing any rings or any other jewelry that somebody may get harmed with. And of course, fasten any type of loose sleeves when working around machinery or equipment, right? Either wearing short sleeve or if we're wearing long sleeve, making sure that it's secured down so there aren't any loose parts. Folks, if you look at the barricades down on figure 3 on page 4, if you notice, look at those barricades. We talked about that, I think, last week or the week before. You see how those stripes on those barricades, orange and white stripes, they go from the top left to the bottom right. That means that we're staying on the right-hand side of those barricades. That's why they're all uniform like that. Okay? So in addition to personal safety, also be alert, right? Not jumping on and off of moving equipment, making sure that it's stationary, parked, and braked before dog down, right? Basically, before we get on it. Equipment has to be at a full stop, right? Park and brake engaged. Also, prior to entering or exiting the equipment, maintaining 3 points of contact when we're getting on or off of the equipment, and then knowing the location of any first aid equipment, fire extinguishers, and emergency telephone numbers. Any equipment that we have, if it make sure it's got that fire extinguisher on it, and any safety devices, any safety guards that it comes with, making sure that they're all in adequate shape as well. Okay. And then, of course, you see your PPE in figure 4 to your right? We see different types of goggles and glasses. Looks like a newer pair of UVEX at the very top of the page. Okay, if anybody hasn't used those newer UVEX like that, they're really comfortable, folks. And they've got some ventilation slots in them as well. If you notice at the very top, it's between the top layer of plastic and then the gasket. Okay, and then gauntlet gloves, right, or electrical gloves. You see your hard hat, or it could just be work gloves that are gauntlet style. Leather boot with the perfect example of preferably wearing lace up. Good toe protection, right? The leather still covering the metal cap or the composite cap. Jeans or pants over the laces or over the boot. And then, of course, high visibility vest as well, right? Folks, for anybody who's not familiar, if you look at those high visibility vests, you can look at the class and type in, or have the class and type in on the inside. Let me show you what I'm talking about, okay? Let's see. As you can tell, the internet's slow. That's what I was talking about earlier. We've been rough all day today. So, okay, folks. So for anybody who's not familiar, if when you're looking at all your equipment, high visibility, the DOT requires class 2 or class 3. Okay, class 1 is no longer allowed, and basically the classes go by the rating of visibility on the vest or the equipment or the shirt themselves. Okay, so this is what I'm talking about here. When you see the classes, you rarely even see any class 1 anymore. There you go. Okay, so if anybody ever needs to know, what you do is you look inside of it. Go to Home Depot, go to Fastenal, Granger, whatever the case is, Lowe's. Check out the inside of your vest, and it'll tell you what the class is and the type is. Okay, so just so you know, folks, and then you can actually just wind up Googling high visibility vest DOT classes, and I think that's going to give you everything. And then you'll be able to start looking and see what all, here you go, folks, what all the different classes are that are required depending on the job. Okay, so not all high visibility equipment is the same. Okay, so let's go ahead and move on. Let's talk a little bit about soil contamination, and I'm at page 6, the top left of page 6. When working at a new construction site, right, performing a demolition. One thing we're going to have to make sure is that there's no biological, chemical contaminants, right? So, because we may have something where we're digging up old septic tanks, sewer tanks, contaminated land sites. It could be hazardous chemicals, or it could be either hazardous chemicals, or it could be biological hazards. Okay, so we have to make sure that we put warning signs up, right? Advising employees if there's puddles of any type of fluids on the ground, especially fluids that are unusual color or odor. We have to report anything that's not on the job work order or on the job training already. We need to go ahead and make sure we report, because it may be a new hazard that wasn't identified during the job hazard analysis. Also, any fluid seeping out of the ground, unusual foul odors, right? Unmarked barrels or tanks, they may be buried and may come up in the ground during the excavation. So we need to make sure that we watch out for that. If you look at the bottom page, you'll also see you got some misters there to reduce dust down. Okay, just different tools and equipment that's available in the market. Also, all types of motorized equipment, right? Use like fuels like gasoline, LP gas, right? Liquid propane gas, could be diesel fuels. So, any of these could also cause a fire. Battery operated, really doesn't matter. So we need to make sure that we keep our risk of LEL down, our explosivity or flammability rates down. Okay, and then guidelines for safe operation of heavy equipment, right? What are we looking at? We want to follow the safety protocols in order to minimize the risk of any injuries, illnesses, or fatalities, right? So what are we looking at? Basic list items, right, that have to be checked daily. Engine performance and gauges, oil pressure and levels, housekeeping tasks, fire extinguishers, making sure all audible warning devices are working, any anti-tube blocking devices are in place and working, and that's on a crane. Like I said, I'm going to be showing you that. I'll probably show you a quick picture of it tonight, because I don't think we're going to make it that far, but I'll show you a quick picture of it just so you know what I'm talking about. Hydraulic lines and fluid. Also, windshield wipers, mirrors, lights, making sure everything that's adequately working. Batteries, charging systems. We also want visible hand signals, load charts, right? Hand signals have to be posted. We must use the hand signals that are recommended by ANSI, by ASME and ANSI. And if we don't use them, and then we must post the signs that our company or organization will use over the signs that are the traditional ones. Okay, so if we're going to use alternative ones, we need to make sure that we cover the ones that are the traditional ones. And then if you look at also, in addition to that, what else are we talking about? Guards and clutches, right? Tracks, wheels, and tires, brakes, locks, safety devices. Um, Also, any type of train drives, chains, steering, rollers. We want to make sure that we protect against those as well. Sheaves, drums, and cables. I'm going to show you what a sheave and a drum is, folks. I know some of you may have not seen it before. Blocks and hooks. Okay. Carrier assembly, and then any other controls, right, including hoisting, swing, travel, and the boom. We need to make sure that we adequately protect on all that as well. Okay. So let's talk about moving heavy equipment. Let me show you this really quickly. It's going to probably be easier right now, and we'll keep on talking if it takes too long. Okay, anti-two block. Here you go, folks. Just so you see, this is for anybody who's not familiar. What we're looking here is this is the lower block, right? Here's the upper block, and this is basically an anti-two block right here. And what this anti-two block is doing is, if it comes up and it hits here, it's basically telling it to stop, and it will not allow the block to continue to go up, because what it may do is pop the cable, or it may damage the blocks as well. Okay, so that's an anti-two block. Here's another example of it. You have different ones. There you go again. Okay, so there's your sensor on it for anybody who's not familiar. Okay, so it's called, like I said, it's called an anti-two block. Anytime, if you ever lift in personnel, like in a personnel basket, the anti-two block, as per the OSHA standards, has to be installed. Okay, and there you go again. You see that's where it will end up being installed. And what it's going to do is, it's basically going to stop the travel block and the hook from raising any higher. Okay, it means the operator went too far. An alarm should have stopped them, or should have stopped already. And what it is, it's just basically it's a redundancy device that's going to stop them one last time, and it's going to be the last. It's going to be the last basically protection. Okay, it's a redundancy protection system in order so that we don't pull the block through the lower block through the upper block of the sheaves of the drums. Okay, and then let me right now. I saw some sheaves and drums, but I'm gonna show you. I want to show you the difference right now. Okay, there you go, folks. So there's your drum right there. Okay, and then if anybody ever talks about, let me show you jumping the sheave. Let me see sheave damage. So your drum is your draw works, which is normally in the bottom. If a wire jumps, it's called jumping the sheave. And let me show you let me show you what I'm talking about. Basically, let's say if a cable is coming up the top of, let me try one last thing. I thought I just saw one. Okay, say we're talking about the top of a crane and we have a sheave, right? You have a wheel coming up at the top and the cable can wind up jumping on the sheave, especially when it's not adequately oiled or if it's got a bird cage in it or a kink in it or whatever, and it wind up damaging the top of the sheave. There you go. Let's see, and you see how that sheave is all damaged right there? That's what I'm talking about. Okay. So anybody if you have time, I'm gonna try to see if I can maybe send you a video and show you where a couple of videos where the sheaves have been damaged. Okay, I think I have one, so I'm gonna have to check and make sure. Okay, so let's go ahead and move on, folks. So what I'm gonna do is I'm gonna cover. Let's see, I'm gonna cover one more section, folks, and then I think we're gonna stop at that point. Okay, so that way. I think we're going to cover this last one section, and then on Thursday we'll pick up starting with the permit, okay, with the operator's daily checklist. Okay, so moving heavy equipment, basically traveling on public highways, whether it's in construction facilities, whatever the case is. First of all, wouldn't try to get an escort, right? And we may even be required to get an escort, depending on what the municipal or what the state or federal requirements are, whether it's a contract or over the road, right? Public works as well, or public roadways. But things we want to do, right, is make sure that we drive slowly and never speed. We also want to make sure we respect the speed limit of what that equipment is, okay? Know the distance it takes to stop safely. Allow extra time to enter traffic. That's why we should be using an escort, folks, okay? Know and follow the traffic control pattern. Travel with the lights on. Use proper warnings and flags, secure all attachments in loose gear. We want to turn cautiously. We want to allow for extensions, right, or attachments of the structures. Some equipment is top heavy. We need to make sure that we respect that so we don't tip it over. Also want to make sure that swing radius, folks, because it may, the back side or the front side may swing out depending on the type of piece of equipment. We have to know that. That's why we have to know the turning radius. We have to know the swing radius of that equipment. We have to make sure that the swing path is clear for any people or any objects. We also have to know and obey all state and federal laws, right, and local laws. Also, we want to follow the guidelines for driving equipment and on a safety site. We never drive a machine in a congested area. Around people without a spotter or a flagger. We talked about that a little earlier. Now we're talking about specifically a crane, right? Spotter or flagger is responsible for determining the direction and the driver speed, which the spotter or the flagger may, but usually we'll have a work order already or a work plan that's going to advise us on probably the plan, the route that we're going to take, barring that there's no significant change. One of the things I tell people is make sure you watch that swing radius and also make sure that we watch the height to make sure that we're not hitting any power lines or any other overhead obstructions, okay? Or equipment or fixtures. Also, be sure that everyone is in the clear while backing up, right, hooking up or moving any attachments. Um, we want to never move any buckets or shovels, over the heads of other people. If you can't see the surrounding area clearly, from the operator seat, we have to have a spotter. Okay, or you don't operate the equipment. All right. Now, not only that, this is the thing, folks, is that we have a spotter. We have to, and this is during crane operations or even moving a crane. Okay, anytime we have or moving a crane whatsoever or doing an operation, if we lose communication with the spotter, visual communication and our audio communication, if we lose both visual and audio, we have to stop exactly where we are until we resume at least one of the two types of communication. Okay. Now that, and like I said, that's whether we're in a crane operation or whether we're in a crane movement. Okay. Um, Wait for an all clear signal before moving. Signal a forward move with 2 blasts of a horn. We're going to signal reverse move with 3 blasts of a horn. Okay, we're going to yield to the right of way to loaded equipment on the construction sites. Loaded equipment is always going to get the right of way over empty equipment or just moving equipment. We want to maintain a safe distance from all other vehicles. When moving or keeping equipment in gear at all times, we don't want to coast. Okay, so it means it's got to be kept in gear, right? Regardless of how slow we go. Maintain the ground speed consistent with the ground conditions, and posted speed limits. We also want to know where overhead electrical power lines are located and ensure that buried pipes or power or gas lines have been located and marked as well, like we talked about. We don't want to have a void or some type of soft ground conditions where we may go through the ground or damage any type of underground services or possibly flip or turn that crane. Okay. And then, folks, you saw the part about the blast, right? Going forward, 2 blasts, going back, 3 blasts. So much of this is standardized. I mean, I can't point out enough how much of this is standardized. Okay. So let me run you through this one last paragraph just for communication. And basically, what are we talking about, right? Operation of motorized equipment. It requires concentration by the operator, right? Can't have any distractions that could wind up in any type of significant injuries, illnesses, or fatalities. At all times, the operator's got to have a clear view of the site, okay, or the equipment. Like we said, if not, they're going to have a signal person or a spotter, right? And they're going to have to maintain a minimum of one type of communication with the signal person, either audio, whether it's voice, radio, and or visual, okay? But at least one form of communication is going to have to be maintained. Okay, and then there are going to have to be many ways, of the operator signal person to communicate, right? There are many ways, like we talked about, radio, signals, okay? And then we have advantages and disadvantages, right? Radio interference. My recommendation is that when equipment is moving, you keep everybody else off the radio, okay? If they're walking all over you, stop operations, determine what you need to do, and then at that point, just make sure that you have safe communications, okay? Also, keep any horseplay or clowning off of the radios as well, folks. If you don't know who it is, change channels. If so, and you continue having problems, you may have to do a radio inventory and determine who's causing problems and remove those radios and or take disciplinary actions, okay? And then hardwired communication circuits, another way, but it's rare. I mean, nowadays we're doing everything for is going to be electronic and wireless. It can be Bluetooth. That's not a problem, folks. That's another option as well. Okay, and then it's got to be hands free for the operator. So the operator has got to be able to listen hands free. They can talk and push the button if they have to, but as far as listening, whether it's moving a crane or whether it's operating it, the OSHA standard is going to say that it's going to have hands free anytime it's being operated, and moving it is part of operating it. Okay. And then, of course, the only disadvantage of the hand signals, right, is that the person's got to be in sight, like we talked about. But if the operator loses sight of that person, and the only thing that they're doing is hand signals, and then we got to stop operations. Okay. So, folks, this is what we're going to do. That's where we're going to stop for the night. Just to let you know what's going to happen on the next session is that we're going to be going through, you're going to see crane signals on the next page. All right. I'm not going to really go through them a lot. I'm just going to leave them there for everybody to be able to understand them. These are all standardized hand signals. Like I said, you can do different hand signals, but if an organization does it, everyone must be trained to the new hand signals, and we must cover the standardized hand signals. Okay. And then we're going to be going into forklift safety, which we've talked a good bit about already. I'm going to send you some videos anytime between now and Monday to watch. We're going to talk about electrical safety around cranes, and that's pretty much going to close out this section, folks. So I will plan on talking to all of you on Thursday. We're recording more sessions. Like I said, we're going into the third book already. So we're going to be doing more and more sessions over the next few weeks. That way, if anybody wants to catch things more quickly, you can feel free to. Okay, folks. So other than that, y'all have a great night. Thanks so much for your participation. And like I said, all this, I'm hoping to start getting these videos loaded up by tomorrow or the next day once our internet service gets better. Okay. Have a great night, folks. Thank you very much.